All right, so yes, most of you will probably know me as the guy that created AXON framework, and this presentation or this webinar is not so much about AXON itself, but more of the some of the patterns that I've seen on how AXON is being used in real life situations, and some of the patterns that I've seen in especially how messaging is done in microservice architectures. Even though I talk about monoliths a lot, and I will do so again in a few seconds, the whole goal of AXON is to allow the creation of structured monoliths and then evolve into a microservices architecture. By now, many have done that, have gone through that process, and have ended up with a microservice architecture. And in this presentation, I'm going to give a couple of examples of the types of messaging that I've seen in those projects. And of course, there's plans with AXON framework for the future that are based on these patterns. So the monolith is a structure that is discussed a lot, probably more in software architecture than in geology, although I'm not entirely sure. But it's often in a context, placed in a negative context. It's often talked about, yeah, it's the monolith that we have to get rid of, and we have to replace it by microservices architecture. Usually those projects, well, fail miserably because destroying a monolith shouldn't be a goal in itself. And I think it's very important to realize whether you're actually talking about a monolith or something else, which in domain-driven design terms is called the big ball of, well, in this case, mud, although we definitely know that it's not actually made of mud. It's a whole different thing. But it's something we don't want to have. And actually, the monolith itself is not the problem. It just says that we have one unit of deployment, which is pretty big and probably not extremely easy to handle. But it does a good job at what it's supposed to do. And we should be aware of the fact that most of the software we use nowadays are massive monoliths that have helped us through the 20th century. So it's the big ball of mud that we need to fight, or even better, prevent. So microservices in itself should not be a destination. And well, this is a quote from Joris, who paraphrased Sam Newman. Sam Newman says it's microservices is a journey. The goal of that journey is something else than the microservice in itself. Microservices are merely a means to achieve a goal where we want to be able to respond to a changing environment very quickly, or we want to have a very fast onboarding process for new developers. Onboarding on a monolith is pretty difficult because every change you make can affect the entire monolith, or small parts anywhere in that monolith. In microservices, changes are much better contained in a single service. So those are goals, and then microservices are a way to meet those goals. So if we look at that journey, what I like a lot is the structured monolith, at least in the beginning of any project. So if you've been watching more webinars, you've probably seen this this flow. I'm just going to repeat it just to make to get the context right again. So what we run the risk of is this monolith that we're creating, that it turns into a big ball of mud, and that's definitely not what we want. So we want to bring structure to that monolith. One of the key aspects of a big ball of mud is the lack of structure. So let's bring that structure, and that's something that AXON framework helps you with by defining the aggregate boundaries very strictly, by separating commands from queries, by forcing developers to to model specific aspects of a system very, very explicitly. And then when we evolve this application, then we can then look at how this application is being used and extract components to support however we're using it. So maybe this blue component that we are extracting in this next step is a component that can live separately or has a different release cycle. Maybe there's a different team working on that. So quite often the deployment units reflect this, the team structure of the software that's being created. So now this blue team can deploy their software independently of the rest of the team. And as we evolve further, we can extract more components, and maybe in this scenario, the orange part, or now the orange team, was a component that needs to scale out because it's being hit more frequently or is more labor intensive than the other components, whatever the reason. If we decide to extract that, we want to be able to do that, and that is the very important but subtle difference between a monolith and a big ball of mud. So what helps very, very nicely, and especially if you're in an AXON framework context, you're probably using this already. But even if you aren't, there's a lot of concepts that came from command and query responsibility segregation, aka CQRS, that helps us define how these components should communicate. So there's in CQRS there's the separation of two important concepts, and one is the command model, which is the model where we handle incoming commands and make decisions on the impact of change. So what happens if a user wants to place an order? Will we accept that? Will we reject it? What are the consequences of that order being placed? And on the other side, we have on the right side, which is the read side, which makes it really confusing. On the projection side, we have these. We provide information to whoever the client is. Might be a user interface, might be an external system, and it supplies the information to the outside world. So you can ask it questions. You can ask, what is the state of the current order? What are the line items in the order? Or maybe even, what are the order details at the moment? Anything like that. And these projections are updated as a result of events coming from a command model. So essentially, we've got three ways components communicate. We've got the client sending commands, which end up being processed by a command model. As a result thereof, we publish events. These events are picked up in the projection side of the application, and they update the current state of their own model. And then clients can ask queries or send queries where these projections will provide the relevant information. Now, another very important aspect of being able to have this microservices journey is location transparency. And the essence of location transparency is that a component, whichever component, is not aware or make any assumptions of the location of a component that it interacts with. So we want to make sure that when we send another component a message, that it's not obvious where that other component is. So the APIs in this are very important, and using explicit messaging is a very nice means to do this. And after this, I'll go into three different forms, basically the command, query, and events that I've also already touched. And using explicit messaging helps in this location transparency, because basically we just say, I send a message. You're not saying where to. So the abstractions that AXON provide help you building this location transparent system. You can imagine if the orange, if the pink or purple component is aware of the fact that the blue component is in the same deployment unit, as is the case in the left part, then you wouldn't be able to extract that blue component, because now suddenly your application will start behaving differently. Obviously, latency will go up, but if there's big for loops iterating through certain information provided by the blue components, that latency will go up extremely fast as when the blue component is extracted into a separate deployment unit. So let's move to these messaging patterns, and I've already identified 3 reasons or 3 different types of messaging, right? So the first one is I want the system to do something. So the system is currently in some state, and I want to change that state, whatever it is. I want to place an order. I want to confirm an order. I want to just something you want to do, right? And you're more interested in the fact that you do something than in any information you get back from that being done. Right? The other one is a notification something has happened. So the order component might want to yell out that, hey, I've got an order. Somebody placed an order with me, because other components might be interested in knowing that. And even in this case, it's much more about the sending than about the receiving. So there's actually no receiving here. You just want to say it happened and then get on with whatever you were doing. And the third one is I want to know something. So there's an application and I want to know something about the current state of that application. So I want to know the order status. And in this case, unlike the other two, the main added value is actually in the response. So you're more interested in the messages that come back based on the I want to know something than you wanting to express that you have the desire to know something. So let's look into these 3. So I want to do something is essentially a command. If you're familiar with CQRS, then you'll immediately recognize this as a command. And essentially, you just request a side effect. You want the application to do something, to be in a different state after the command than it was in the, before. Of course, commands can be rejected, so maybe your intent was perfectly valid, but not at the moment. In that case, the application in the end is the same as it was in the beginning, but at least the intent was there to change it. Another example could be you want the system to send an email. Commands in CQRS, or at least in how I've seen implementation so far, have exactly one destination. So you want a component to do something, and there's exactly one component that should react on that. Maybe as a side effect, multiple components can react to whatever is happening as an effect of that command. So you can trigger a lot of changes. But you have one initial destination where that command's being handled. Commands have some sort of a reply just to say it's been okay or not okay, and maybe in some cases you also want to return some data to give the sender of the command a bit of context in how the command was executed. But it's very important to realize that it should not be about the data you get in return, because then it's a query. So routing commands is pretty simple in theory, but you have a component that wants the application to do something, here depicted on the left, and it needs to route that command to something on the right side. So in this case, we have 3 components that can actually do that something that the component wants to have done, and to write that message, we just pick one. Right? We can pick the first one, the second one, or the third one. It doesn't matter, because they all can do it, and hopefully they trigger the same side effects. They might even have different versions if you want, so the side effects could even differ, but it's not the sender the sender's business logic should not decide who can actually do that. It should be a technical decision on where to route that message. So at least this is how AXON does it, is you route a command based on the target of your intent. So you can, for example, use an aggregate identifier if you have one. So I want to confirm an order. Then that order is the target of your intent. So you can base the routing on the order ID of the routing. So you can say, well, if modulo the order ID modulo 3 is 0, I send it to that component. If it's 1, I send it to the other one, etc. So these routing decisions can be made consistently across a whole line of clients trying to send the command. And that allows you to cache information about that order on a specific destination, because you know that every command for that destination will arrive there, as long as the configuration of our deployment environment doesn't change. Now, in practice, you wouldn't want to use the modulo as a hash function, and AXON doesn't use that. It uses the consistent hashing algorithm to route, which is a lot better when it comes to changes in the number of nodes. But there's other ways to route it. You can also do round robin. Just put a simple load balancer in front and rotate the requests. You can even pick a random one. You can base it on SLAs. You can so have the high-profile users sent to specific machines only, and the rest of us to other nodes, to ensure that certain users that have strict SLA requirements that you meet those SLA requirements. And another one, a concept that's pretty interesting, although in practice I don't hear a lot of good news about it, is to base it on the actual load. So essentially, the higher the CPU on a machine, the lower the load you send to it, it becomes. That will give you massive fluctuation and very weird responses. It's probably great fun to look at the graphs that it creates. But it's nice in theory, and you probably need a very good algorithm to make sure that that's balanced. But either way, you can route any way you want, right? As long as there's one destination, and that the preferably client can decide on what that destination should be, not in the business logic, but in some application framework level, technical level of the application. Now to another message. Something has happened. Something, if you're into domain-driven design or CQRS, you'll immediately recognize as the event. And the event is a notification that something has happened, and it may mean there's a data change, right? Somebody has changed information in the system. So it doesn't really contain the change itself, but it describes the change. So an order has been confirmed, or items have been placed in the order, or the address has been chosen, etc., etc. But it could also be that something external has happened. Maybe something on the clock happened, right? A deadline has passed. You should have paid this in 30 days. You didn't, and here's an event to indicate that a deadline has passed. Essentially, an event can be anything that is relevant, which is very easy to say and very hard to recognize in real life, because there's so much happening. How do you decide is relevant? Well, that's a different topic altogether. There's a lot of, especially domain-driven design-related talks about this, on how to decide whether it's relevant. But usually it's when people talk about it, and when it's subject of conversations, then it is apparently is relevant in the context that you're working. Routing events is slightly different than routing commands. So events have a more publish subscribe style communication. There's a component that wants to tell the world something happened. It doesn't care about what other components do with that event. In fact, it just wants to send it out because probably it has to, and then move on with doing its own job. So the publish subscribe pattern, pretty simple. You send an event and everybody who wants to know about that event gets the message and can do whatever it believes should be done when something like that happens. In practice, you also see quite often that you have multiple components where only one of these components should be notified of an event. This is also already supported in AXON. You can have exclusive consumers. So you have something that happened, and there's two components where one of them wants to know it, and there's a third component that wants to know everything. So now you could route the event to one of us wants to know components, forget about the other, and send all the messages as well to the want to know component, the third one, the bottom one. But that will have one machine be really busy processing events and the other one doing nothing, essentially just waiting for that one to die and then take over from there. It's nice for high availability, but it doesn't allow you to scale up in terms of numbers of events you process. So alternatively, what you can do is have competing consumers. And this is where it becomes a bit interesting, because the sender cannot know how the handlers compete for messages, because it doesn't know what they do. It shouldn't want to know what they do with that message, right? So the sender in this case will still just send the message, and then the consumers will decide based on whatever aspect of that message on whether they will handle it or their sibling right next to them will actually handle that. So in the case of an order confirmed, you could say, well, if they update the order status query model, that you route based on order. So if the order is the same for two events, then you route it to the same machine. And if it's different, they may be routed to different machines. So you can actually have a modulo function to decide on which component takes up which portion of specific events. And this is currently not available in AXON itself. We are building this, and it will be available as from version 3.1, where you can have balanced consumers. We have multiple nodes handling the same types of events, doing the same thing based on those events, but then balance the load between these nodes. And then there's a third type of message, which is the query, which is a desire for information. And the response to that query holds more value to the sender of the query than actually the query itself. Queries are usually also side effect free. So asking, there's a nice quote saying, asking the question shouldn't change the answer. But you see in a lot of systems that queries actually do have side effects. There's maybe quota involved, or logging of data access by a specific user. We have a number of use cases in the medical domain, and it's very important to track who has accessed which medical record when. So there is, in fact, a side effect when you do a query. Although it doesn't change the answer. The fact that you ask the question doesn't change the answer to the question. The query has very interesting aspects to it when it comes to messaging patterns. And until now, AXON didn't really give a lot of attention to queries because we've always said the query is not really that much different from how applications do requests anyway. So why should a framework interfere? Well, we've seen some patterns now that make it actually very interesting to interfere with that part. So the upcoming versions of AXON will provide a, well, probably called a query bus, where you can implement these queries. But for now, let's look at the patterns. So a very obvious and very simple pattern is the point-to-point style communication. There's a component that wants to know something, there's a component that knows something, and you can just ask that component for that information. In this example, give me a price, and whatever the price is the result of the query. And there's a component that says the price is 49 for whatever that component or whatever that object is. This works very nicely for questions that have a single true answer. But we also know that in real life, not every question has a single answer. There's a lot of systems that have opinionated answers or have a lot of different means to get to an answer based on information that they have available. And I'm going to use a little example in the from the travel agency. You want to be able to offer your users a specific trip for the lowest available price that is relevant for that user. So there might be two different components now. One is just the catalog that just sends out the list prices of specific trips. But maybe there's another component that looks at the profile of a user and sees if they are eligible for discounts, or that it might be for customer satisfaction reasons, a very good reason to offer that to the specific customer for a lower price. So now what you want to do is you want to send a scatter-gather query, or map-reduce as you will. You send the query to basically the entire system, and it will end up in a lot of different components that can answer, that can provide an answer to that query. And then you say the result is the lowest price I get as a return, and I want to wait a maximum for 100 milliseconds. Because now the sender doesn't know how many components will be reacting to that query. They might differ from time to time. Maybe you want to wait for the first one, but in this case we want to wait for the 100 milliseconds and take the lowest available price. Now the component in the top will always answer 199. The component in the bottom may answer, if the conditions are right, with a different price, maybe 149. So if these conditions are met, the price will automatically drop to 149 in that situation. That's interesting because if that component fails for whatever reason, now suddenly the default list prices become the standard prices, so we have some gradual degradation. Of course, it won't help customer satisfaction anymore, but it's a lot better than doing point-to-point queries and not being able to get to that component. And even better, there, especially in the travel industry, but there's many other domains where this is relevant, there's quite often these temporary marketing actions that you have where you say, well, the Asian destinations are now 99 because it's the Asia days today. I don't know why, but so if the travel is to a city somewhere in Asia, the price is 99. And of course that will win the min price battle on the left side. So that will definitely be the actual price displayed for the user becomes 99. And as the Asia days come to an end, we just shut down that component, and that's it. That's all we need to do. So we can deploy new functionality without impacting any other component in the process. We just provide a different answer, and it's up to the sender on how they want to decide to incorporate that answer in their actual results. But then this is all nice, but if we build systems like this, and usually components in AXON are built with AXON because you want to be able to scale at a later stage. And as I said in the beginning, we see a lot of projects now that are operating AXON at large scale, and we see that different rules apply, and we know that, right? So how do you route all these events and all these queries and all these commands to all these components? I mean, how can you scale that to large proportions? Fortunately, there's a very easy answer to this question. You don't, because it simply won't scale. This solution does not scale. Well, it does, but not in a naive approach. Because what you eventually get is a distributed monolith. Everybody's talking to everybody. And if you take this example, so the orange dot in the middle merely means that components are communicating with each other, thus sharing some form of language to communicate. It doesn't mean that messages are physically routed via a central hub or something. That's a completely different discussion. But maybe the green component is a shipping module, and it wants to know when an order is placed. So the language the shipping guys use is an order is placed. But that is obviously not the language that the order component is using, because the order component is responsible for the life cycle of the creation of an order. So they talk about there's an order created, there's items added to an order, there's a shipping address added, billing address, and then the order is confirmed. So when the order placed is actually a combination of all these 5 types of events. So it's the fact that an order is confirmed is the trigger of an order placed, but inside the order placed, you probably want to know what has been bought, by whom, and where is it. So where are we supposed to send it to? Because this is a shipping module, right? That wants to know. So it probably wants to know everything. Now, one of these components is going to have to learn the language of the other one. So it's either the shipping module that listens to all these events by the order created, shipping added, etc., and then throwing everything away when an order canceled comes in, or is it going to build up this order placed event because it sees that all these events have occurred? So essentially the green component is then taking over a lot of logic from the pink component, the order management component. Now this might work for one module talking to another module, but as soon as systems grow, basing everything on events is going to result in a big mess. We need something else to manage this. And the answer isn't far away, fortunately for us, and it's actually the concepts that I stole, quote unquote, these concepts from that gives the answer. And it's domain-driven design. It explains the concept of a bounded context. And I'm not going through the entire definition, but essentially it comes down to you organize components into contexts because they speak the same language. They share certain problems that they work on that makes them talk the same about certain aspects. I often use the example of a flight, so with an airplane, air transportation, to explain the different contexts. So me as a passenger, I'm just interested in knowing which gate will my plane depart from, at what time, and what terminal, etc. So I know when I have to be somewhere, and then I have a seat number. But for the ground crew, for them the arrival time of an aircraft is actually the time when it arrives at the gate where it departs for me. Whereas for me, the arrival time of an aircraft is where it arrives on the other side of the planet or wherever I'm going. So we talk about the arrival time in very different ways. So I don't share the language with the ground crew, which is not a problem because I hardly have to talk to them anyway. But that's in terms of software, that's very important to realize that we choose different aspects of the problem because they are or are not important to specific in a specific context. So if we map that concept of bounded context to the unmanageable mess that we have, we now start to see that the pink components, the order components, they share the same language. They are concerned about the flow of orders and how they're created and how the life cycle is being managed, and the same for the shipping components. So within that context, you probably want to share all these detailed events. right? An order is created. But outside of these contexts, you want to share more consciously, and probably on a level of language that is a higher abstraction level than the messages in the middle. So to come back to our example, this is the shipping module that wants to know when an order is placed, and this was the module that sends out all these events. Now there should be a component on the edge of the bounded context saying, well, I'm translating whatever's happening inside to some more common language. So I'm saying the creation and items added, etc., and the order confirmed. If that happens together, I'm going to publish to the outside of this context the fact that an order was placed. Now I'm not forcing any external components to learn the language and all the intricacies that it brings to be able to deal with orders. So AXON framework in itself helps these components, each individual component within the bounded context, by providing these APIs. Right? There's the event bus, command bus, and in the future you can expect a query bus as well. We provide the abstractions to send messages or to receive messages, and that works very nicely within these components. But AXON itself doesn't help you with the how do I route these messages, right? It helps with the separation of the business logic and infrastructure, but still the messaging patterns are there for you to implement, just for now. And we've noticed it's pretty hard to get this messaging right. There's a lot of questions on the mailing list that we get. There's even more questions straight to our support crew in support contracts that we have about getting this messaging right, because it's a very subtle thing. But we've identified these patterns essentially from all the questions that we've got, and we've noticed that we're solving the same problem all over the world. It doesn't matter where the projects are, we are solving the same problem again and again. And there are certain tools that we have to do messaging. There's message brokers, there's a lot of stuff, but every time we need to make the decision again to which tools do we use for which messaging pattern, and how do we get messages from A to B, how do we translate them? So we've noticed these messaging patterns, but we've also noticed that the solution to those messaging patterns are a pattern in itself. So we were thinking, what if we didn't have to bother about that anymore? What if we could really focus on the fact that we want to send out an event and be able to rely on the fact that it will get there, it will get to its destination? What if there was some sort of a platform, quote unquote, that could take care of all the messaging stuff that we have, realizing that we send a command, a query, or an event. Just like how we can have platform nowadays take care of all the deployments and discoveries. If you use Kubernetes, you just deploy an application. You're not concerned about where's enough resources for me to deploy that, or how do I actually manage the fact that I want 5 instances of this, and where can I find them? All that is abstracted away into, in this case, Kubernetes. But what if we could do the same with the messaging that we have, and just say, I've got a question and I need an answer to this question right now, and that a platform will take care of getting that answer for you. And that's exactly the mission that we have set ourselves for the future of AXON. Our mission is now to provide an API, an implementation, obviously, necessary for these event-driven microservices, where event is just one of 3 types of messages, but to have them cooperate harmoniously and allowing each of them to just focus on the business logic and express the fact that they have a question and they require an answer, but that they don't need to, or that at least the developers building that don't need to worry on how to get that question across to the components. This is actually what we're already working on. It's called AXON Platform. If you want more information about it, don't hesitate to send us a message. We will send you an answer as soon as we can. Whatever questions that you have or comments, I also ask you to send any comments. So that's it for now, and well, thanks for listening, and I hope to hear from you soon.